All right, hello, beautiful people. Right now I'm going to go over the Fitz factoring feedback with you all that had some questions on how to do some of the problems. So I'm going to do all of them in this quick little video just to see how you're doing. Number one was 4x squared plus 12x plus 5. There's not a GCF, there's not a number that goes into 4, 12, and 5. For next, I'm going to go ahead and put the first term in the first box and the last term in the last box. Then I'm looking for two numbers that will multiply to give me this product. So multiply to give me 4 times 5 is 20x squared. And I want them to add to give me that middle term, which is 12x. Always add to be whatever the middle term is, and always multiply to give me whatever this product is. It's also when you multiply the first and last terms. And so thinking about it, I'm thinking I'm going to go for 2 and 10, because 2x times 10x gives me 20x squared, and 2x plus 10x gives me 12x. So I'm going for 2x. Again, it doesn't matter which one you put where. Then factoring using my factor box, the 4x squared and the 10x, well, the 4 and 10 have 2 in common, and then x squared and x have an x in common. Then look at the next column, and I have 2x and 5. They only have the number 1 in common, so I'm going to just write that. And then I'm going to start with this row here. 4x squared and 2x have 2x in common. And then 10x and 5, 10 and 5, they both have a 5 in common. So my answer is going to be 2x plus 1 and 2x plus 5. Okay, for the next part of the Fitz feedback, I was trying to see if you could identify the correct special pattern. So here were my special patterns that we had learned before, and these are the two examples that we had. So for number one, it starts and ends with perfect square. That's how I know I can use this. And so I have p squared and 36. It's a trinomial, so my options are going to be this one or this one. And because this is subtraction in the middle, I'm going to go for this one. So p squared, boom, boom. What I'm trying to find out is what this is, like what squared equals this. So to do that, I need to find what the a is and what the b is. So I ask myself, what times itself gives me p squared? P times p gives me p squared. And if this is minus in the middle, this is minus in the middle. And so what times itself gives me 36? 6. I don't know what letter choice that was, but that is your correct answer. Okay, part 3. I have 9a squared minus 64. It is a special pattern. It does start and end with perfect squares. There's also not a number that goes into all these. There's no GCF. So I'm going to use this one because it's just crossed it off. I got a little angry. This one is what I'm going to use because it's a difference of 2 squares. The difference of 2 squares. So when I have that, I'm going to have kind of the same thing repeated, except one is plus and one is minus. I'm going to ask myself the same thing I had to ask myself for number 2. What times itself gives me 9a squared? Well, what times itself gives me 9? 3. What times itself gives me a squared is a. So 3a and 3a. If I multiply those, I get 9a squared. Then what times itself gives me 64? Well, 8 times 8 gives me 64. And then from here, either one plus minus, it doesn't matter which order you put those in. Okay. Next thing we had is for number 4. 4m cubed minus 6m squared plus 10m plus 15. Is there a common factor? Notice I'm asking myself that first for every single problem. There's not a number that goes into 4, 6, 10, and 15. The 15 kind of ruins that for me. And they don't all have m, so I can't take an m out of all of them. No GCF. There are 4 terms. The fact that there's 4 terms is important to me because when there's 4 terms, I'm going to factor by grouping. So I group the first 2 and the second 2 together, and I'm going to kind of let my eye just look right here for a bit first. And 4m cubed minus 6m squared, what do they both have in common? They both have a 2. They both have m squared is the maximum I can take out of both. So when I factor that out, I put my leftovers in parentheses. 4 divided by 2 is 2. I had m cubed. Initially, I took 2 of them out. I have just 1 m left. Minus 6 divided by 2 is 3. And this had m squared. I took all the m's out, so it's just. And I can kind of check myself by multiplying it back. 2m squared times 2m, boom. 2m squared minus 3, boom. Okay, now for the next pair. I'm looking at these two terms, the 10m and the 15, and they both have a 5 in common, a positive 5, and nothing else. So my leftovers will go into parentheses. 10 divided by 5 is 2. I still have an m there. 15 divided by 5 is 3. Now I'm looking at these two as just regular old terms. Here's a term, and here's a term. And they both have, miraculously, 2m. Oh, they don't have that in common. What happened? Womp womp. I think I wrote down the problem incorrectly. I did. Initially, they were 3. My fault. So now, miraculously, they do have the same thing in common. 2m plus 3. And then what's left over if I group those together is 2m is still left here, 2m squared plus 5. 5 here, 2m squared. Those are my leftovers that I just put into parentheses. Okay, number 5. Some folks see a word problem and they start freaking out automatically. It's not that bad, I promise you. So it was shipping box, and it had the dimensions of a volume of this, and volume is equal to length times width times height. And they want me to find the dimensions of this. That's their goal, is for me to find the dimensions. So I'm going to break this down likely into 1, 2, 3 factors so that I can see which one's length, width, and height. So I'm going to factor 12. And I'm first going to look to see, is there a GCF? And there is. What goes into 12, 32, and 24, if I'm right? And then they all have at least one X in common, so I'm going to pull out one of them from all terms. And then I'm going to look at my leftovers. So what's 4 is 3. I had X cubed and I took off an X, so I'm going to write that as X squared. Plus 12 divided by 4 is 8. I had X squared for this one and I took off an X, so I have just an X left. And then 20 divided by 4 is 5. And I had an X, I took it out, there's none left. Here I'm going to do what we did for number 1, which is to factor. So I'll use a box for this. First term, first box. Last term, last box. Again, I'm going to look for this product. So they need to multiply to give me 15x squared. And they need to add whatever these two numbers are to give me 8x. My two numbers multiply to give you 15 and add to give you 8, 5x and 3x. 5x and 3x. Okay, factoring using my factor box. These two have 3x in common. 5x and 5 have a 5 in common. 3x squared and 5x have just a I don't have an x in common with anyone. 3x and 5 have a 1 in common. So if I were going to write that, it would be 3x plus 5 from here. And then I would have x plus 1 from here. But initially, don't forget, we did factor out that 4x. So I'm going to bring that down. Length times width times height. I have 3 factors. All right, hopefully that clears some stuff up. If not, I hope to hear from you. A request for Zoom, because I'm available. And I would love to make sure that we don't leave anyone behind with the stuff. So let's start doing that. I would prefer for you to contact me so I don't have to kind of stalk you down. So Let's get these Zooms going. Thank you much. Miss you much. Take care. Bye bye.